Alright, so welcome back to OneClass. Again, sorry for the technical difficulties that happened earlier on. We were doing we had some trouble accessing the questions onto the portal, but now we've gotten back. So we're gonna continue on with what the previous question set was. It was basically questions from kind of grade 9 and grade 9 algebra, grade 9 geometry, and whatnot. So we're going to do, and pre-algebra. So we're going to do questions pertaining to that topic. Again, if you're tuning in for the first time, again, I did an earlier stream at 10 a.m., but there were some technical difficulties, so I'm just going to resume what I was doing before. Again, if you're tuning in for the first time, thank you so much for watching. Again, we're here at OneClass, what we're doing is providing solutions and to questions that have been asked by you all. So that's kind of what we are. Again, my name is Joey. I'm currently a secondary school educator uh, in Ontario. And what my goal is to do, for me to do, is kind of teach you these concepts through verifying these solutions. So without further ado, let's get started on these problems here. Let's get right back to it. So we stopped actually here. We did a problem earlier in terms of rates and discounts, and we finished that solution here. And if you were tuning in or just tuning now, basically what the question was asking, we wanted it to express a single rate of discount for 3 discounts here, so 5%, 10%, and 15%, and we want the percentage of the item, right? So we said that the percentage, we said that the total cost of the product here was $100, and then what we're going to do is we took 5% of that first, so $5 discount, and then we subtracted it by the total cost. We did the exact same thing. We took 10% of this amount here, $95, and then we subtracted that amount by the total cost, and then we did the same thing for 15%, and then finally we had this amount here, 72.68. What we did was we took the initial cost of the product, which is $100, subtracted it by 72.68% to get the rate of discount as a single rate, which is 27.32. So that was kind of our question that was question 1 here. So let's move on to question 2. This is asking us, what is 4/5 as an equivalent fraction? There we go. So what is 4/5 as an equivalent fraction? So when we talk about this concept of equivalent fractions, what are equivalent fractions? So take a moment to think about this question here. Let me rewrite this. What are some equivalent fractions? So when we talk about this concept of equivalent fractions, and what we have here is we have 4/5, right? We have 4/5 here, and that's one of our fractions here. What we can do is we can do the opposite of reducing a fraction. When we talk about equivalent fractions, there are fractions that are equivalent to each other in terms of proportion, in terms of the ratio, right? So when we talk about 4/5 of something, if I multiplied a number in the numerator, if I multiplied a number, say let's say 2, to the numerator and the denominator, so times 2 and times 2 here, I would get something like this. I would get 8 here. 4 times 2 is 8, 5 times 2 here is 10, right? So 8/10 is also an equivalent fraction, right? Because if I know how to reduce this, I can simply just divide the numerator and the denominator by 2 and get back 4/5, right? So if I multiply, I'm doing basically the opposite of reduction. So if I were to reduce fractions would equal dividing numerator and denominator by a specific number, or by the same number. If I were to find out equivalent fractions, so the opposite of reduction would be equivalent fractions, right? If I wanted equivalent fractions, instead of divide, I would multiply, right? Multiply, and then the exact same thing. Multiply numerator and denominator by the same number, right? So if I have that, then I'm basically just dividing. I'm just basically finding multiples, right? So basically for equivalent fractions, what I'm trying to say is that there are actually an infinite amount of equivalent fractions, right? And why I can kind of show you this is because I can multiply by 2, which we get 8/10. I can take 4/5, I can multiply it by 3, I would get 12/15. I can multiply it by 4, multiply by 4, and get another equivalent fractions. These are all equivalent fractions here, right? These guys here are all equivalent fractions, which means there are actually an infinite amount of equivalent fractions, right? When we talk about any fraction here, we have an infinite amount of equivalent fractions for any fraction. And it's not specifically to 4/5. This is for anything here. So 8 over 10, 12 over 15, 16 over 20. Basically, I'm just changing. What I'm doing is I'm changing these values, right? I'm changing what I'm multiplying by. In this case, it's 2, it's 3, it's 4, and then I can go 5 and so on and so forth, right? I can multiply all these numbers by numerator and denominator by 5 to get an infinite amount of equivalent fractions. So this here, the solution here is correct. It says basically there are infinite many fractions of any rational number. To find equivalent fractions, simply just multiply the numerator and denominator by the same non-zero whole number and a rational number in rational numbers. So basically this here is correct. The solution is correct. 4/5, 8, 10, 12/5, 16 over 20. All of these are equivalent to 4/5. So this here is a great solution and analysis. So the solution here is correct. Sweet. Let's look at number 3. Happy that this is working again. So number 3, this is how do you convert 0.7 repeating as a fraction? So convert 0.7 repeating would just have the dash here, right? So this is 0.7 repeating as a fraction. So basically what I'm doing is I'm figuring out what this is as a fraction, right? So if I want to convert this into a fraction, what I have to do is I have to first convert this. This is a decimal here, right? I'm given a decimal, and I want to convert it to a fraction, right? In order for me to convert anything in terms of a fraction, from a decimal to a fraction, what I have to do is I would have to simply divide it by 10, right? So I would have this is 0.7 bar, and basically what this means is that I'm converting this to a fraction, right? So in order for me to get a fraction, what I could do is this would be simply 0.7 bar over, 7 bar over 10, right? Repeating 7s over 10 here, because this is again one decimal place here, right? So repeating 7s over 10, right? But again, I'm not given, I want it as a repeating as a fraction, right? So again, this here doesn't really exist, right? Repeating 7s over 10 doesn't really exist. So what I have to do is I have to find out, okay, what would this be in terms of an actual fraction, right? Because I can't have this repeating saying here. So what this student did here was they just simply let x equals 0.7, which is great. So basically they let x equals 0.7 bar, and then basically what they're doing is they're multiplying both sides by 10 here. So they multiplied this side by 10, this side by 10, and they would get 10x equals basically 7.7 bar here. 0.7. Sorry, give me a second. We multiply here by 7. I would get 7. No. This should be 7.7 bar. 7.7 bar here. That's good. And then basically what they're doing now is they're kind of doing this substitution here, right? So they're saying that they're going to do a substitution and say this here is equation 1, this here equation 2. I'm going to substitute 1 into 2. So they wrote substitute 1 into 2. So therefore you have 10 multiplied by 10x. 10 you have 10x minus minus x equals 7.7 minus 0.7 here. So that's what they're doing when we substitute those things here. And then this is simply just 9x equals 7.0, which means x would be 7 over 9. X equals 7 over 9. So this here is kind of equivalent to 0.7, which this here would equal 0.7 bar. So there's actually an easier way to do this besides substitution. What you can do is there's kind of a cheat when we're talking about kind of expressing fractions into repeating fractions here. And the cheat here is that if I have something that's like in terms of fractions, if I have 1/9, this would equal 0.1 bar. If I have 2/9, this is 0.2 bar. 3/9 is 0.3 bar, and you kind of get the pattern here. So every time we do something over 9, it's simply just that number repeated itself. This rule only works from basically from 1 to 8. From 1 to 8. So all the way up to 8/9 equals 0.8 bar. So that's kind of the cheat here, which means therefore 7/9 has to be 0.7 bar here. So this is a cheat in order for me to like not do the substitution, and I can kind of memorize this and say that, oh, I know that the decimal here is 0.7, and I can always prove it to you, right? Like in terms of if I were to convert 7/9 back to a decimal, right? If I were to convert those two things back to a decimal, I would simply take 9 and divide it by 7.000, right? And this here would be 63. And as you can see here, this is just simply 7, just repeating itself over and over again. So this is 0.7 bar here. So that's basically what this question is. So this solution is correct. Solution is correct. Good analysis. Sweet. So that's I believe that was number 3. Yeah. 3. Let's do 4. 4 is another measurement question. So it's asking us how many quarts are in a gallon. How many quarts are in a gallon? And basically, this question is very, very easy, right? Again, we're working in the imperial system here, and we're talking about measurement, right? This is imperial system. So basically, we're looking at, okay, what's our measurements, right? So let's say we know that 1 gallon here equals how many quarts here? And we know for a fact that 1 gallon equals 4 quarts, right? And then we can say 1 quart equals 2 pints. 1 pint equals 2 cups. Then 1 cup equals 8 fluid ounces, right? So we have all these measurements that we should know by now here. And the question is asking how many quarts are in a gallon. Well, I don't have to do a conversion here, and I can simply say that 1 gallon here equals 4 quarts. So this solution here is correct. 1 gallon in 4 quarts. So this solution here is correct. Great solution and analysis. Very easy question here. That's good. How many feet in a mile? Again, another conversion question. Another conversion question here. How many feet in a mile? And again, what we have here is, again, this is again in the imperial system. So we know that 1 mile first equals 1,760 yards, I believe. Let me just double check this. 1 yard is 1,760. Yes, 1 yard equals 1,760 yards. We know 1 yard equals 3 feet. We know that 1 foot equals 12 inches. And that's about it for the imperial system. 1 foot equals 12 inches, right? So it's asking us how many feet in a mile. So we want to go from feet or miles, so mile to feet here. So in order for us to do that, we have to actually do a conversion, right? We have to say that, okay, well, I have first, I'm going to do this in blue. Well, I have 1 mile. I have 1 mile. I'm going to multiply by, first I have to convert miles to yards first, right? So I'm converting miles to yards. There are 1,760 yards per 1 mile, right? And then there's 1 yard equals 3 feet, right? So I would say 1 yard over 1 yard, sorry, 1 3 feet in a yard, right? So 3 feet in 1 yard. So therefore, this would give us our answer here, right? So I have 1 mile. I'm converting 1 mile here. I'm going to convert to yards first and then convert to feet, right? And as you can see, my units here cancel out, right? So I have miles. Miles will cancel out here. Miles and miles. Yards and yards. So I'm only left with feet here, right? Which is actually the unit I want, right? I want how many feet are in 1 mile, right? So in 1 mile, I have 1 times 1,760 times 3 here, right? So this is simply just 1760 times 3 feet, and this number would equal, let me just do this on my calculator, 1760 times 3 would be 5,280 feet. So there would be 5,280 feet, and this would be our answer for this question here. 1 mile equals 5,280 feet here. So this here says foot and mile are both units of distance in both the empirical system. That's good. Therefore, we can convert miles to foot or foot to miles. A mile contains 5,280 feet. So this solution, good solution, can provide step-by-step analysis using dimensional analysis, converting from miles to yards and then to feet. So the solution is correct here. That's good. That was question 5. Let's work on question 6 now. How do you find the square root of 361? So 361, we want to find the square root of 361 here. So we want to figure out first, let's figure out first a factor of 361 here. So let's see. Factor of 361. So we want to figure out, okay, can we break this square root into 2 different square roots, right? Can we find a factor of 361? So 361 is kind of actually hard because 361 is not even. So they're using this as well. 361 is not even. That's what you kind of inspect this. It's not even. The sum of the digits is not a multiple of 3, right? If I add up 3, 6, and 1, I would get 10, and that's not a multiple of 3. So it's not division of 3, which means I can't divide it by 4 because it's not even. I can't divide it by 5 because the last digit is not 5 or 0, which means I can't divide it by 6. Can I divide by 7? Let me try 7 here. 361 divided by 7. Divided by 7 would give me, I would get a remainder. So it would not be 7, which means I can't divide by 8 because I can't remember. I can't divide by any number. Can't divide by any even number, right? So therefore, I have to try odd numbers, which means, so let's see. So 3 doesn't work. 5 doesn't work. So 3, 5, those are exhausted. 7 was exhausted before. I'm going to try 9 here. 361 divided by 9 would also give me a remainder, so 9 doesn't work. I can't divide by 10 because, again, or I can't also cannot divide by 5 or 10 also, because my last digit is not 0 or 5, right? So 9 doesn't work. Let me try 11. 361 divided by 11 would not give me a value as well. I still get a remainder. Let me try 13. 361 divided by 13, also remainder. 15 wouldn't work because, again, I can't divide by 5 or 10 or any multiple of that. I'll try 16, doesn't work, so I have to try 17 here. Divide by 17. 17 doesn't work. 18 doesn't work because it's even. And I have 19 here. Let me try 19. And 19 does work, right? If I divide 361 by 19, I would get actually 19, which means the square root of 361 would be 19. And we can only basically do this if we're not given a calculator, right? Or if we're given a calculator, we can just shove this in and we'll realize this equals 19. So if I were to divide, again, 361 divided by 19 here, divided by 19, you're going to realize that I have 1, so 19 times 1 is 9. This would equal 17. and then bring down the 1 here, and then you realize this here has to be a 9, right? 9 times 1 is 81, plus 9 here is 70, so this here would equal 0. So 19 would be my answer here. 19 squared is because, so I can say since 19 times 19 equals 361, therefore square root of 361 equals 19. And this here is the only kind of solution I can do without using a calculator, because I would have to basically try out all these factorizations to find out what it would divide into. So this here solution has correct. They did the exact same thing as I did if I wasn't given a calculator. This great solution and analysis. Solution here is correct. Awesome. So that was number 6. Let's do 7. A company has sales of $695,000 and a cost of goods sold at $278,000. Find the gross profit. So it says here sales will equal 695,000, and the cost of goods is 278,000, and it's telling us what's the gross profit. What is the gross profit? So when we talk about this is in terms of business, right? But it's actually a very easy thing. Sales. What does sales mean? Sales means that what's the amount of money that we collected by selling its goods, right? So if we you can think of sales as money collected from, you say from customers or something like that, doesn't really matter, whoever buys it, right? And the cost of goods is basically if we were to make the product as well. Let me do board games. Actually, board games is a great example here. So let me use an example here, and I'm going to say we are a board game company, and we're selling board games. So sales would be basically money paid by customers for board games. So basically the money we're collecting. Cost of goods is how much we as a company need to pay to basically make board games, right? So money paid to create board games. And it's asking what's the gross profit. So what is how much money I have left for company. So you can think of it as this way, right? Sales is the money paid by customers for board games. Cost of goods is money paid to actually create those board games, and money I have left for the company. So money, what's the money I have left, right? So simply what we can do is we can kind of create this equation where we have the gross profit. We can relate the gross profit to the sales minus the cost of goods, right? So gross profit would equal basically the sales minus the cost of goods here, right? And this will give us the money that we have in our pocket here. So gross profit is sales, which is 695,000, minus the cost of goods, which is 278,000. This will give us a value of, so this is how much money we have left in our pocket, right? Or that I can use to pay employees. I can, if I'm a one person company, it all goes towards me. This is $417,000. So this here is my gross profit. And as you can see, this here's correct. Right? Gross profit equals sales minus the cost of goods. This solution is correct. Great analysis. That's number 7. That's good. And now we have number 8, which is a geometry question. It says, which of the following statements is false? Let me write these down first. It says, every chord is a part of a secant. Every diameter is a part of a secant. Every chord is a diameter. Every diameter is a chord. Okay, so let me break this down first. So it says every chord is part of a secant. So let's define here what is a secant and what is a chord and what is a diameter. So let me draw this out for you. I'm gonna draw a circle because that's what we care about. Here is our circle, right? So in our circle, we have a chord, right? A chord is basically a line that stretches from one point of the circle to another. So this here could be a chord. From here, this point to here, this will be a chord. From this point to this point will also be a chord. Basically, from one point to another is a chord, right? So these guys are all chords. So let me write this down. So basically, chords are basically from one point to another. It does not matter where you start, right? So chords, this here is a chord. So from one point of circle to another. Basically, I could also have this here could also be a chord here. Let me do this here. This could be a chord as well, right? These are all chords. So it's saying, is every chord part of a secant? So what is a secant? A secant basically just states that it's a line that intersects the function or whatever shape you have here at 2 points. So secant or secant line intersects basically shape at 2 points. So in this case, if we have this chord here, we're going to see that this is a point here and this is a point here, right? So I have a point here and a point here. It intersects it. This is intersecting. This is intersecting well, which means I can say that chords also equals secants, right? Because they both intersect here. So A here is a true statement here. A is true. B, every diameter is part of a secant. So what does it mean when we talk about diameter? So let me do this in blue. A diameter goes through the midpoint or the center of the circle. So I'm going to assume that this here is my diameter here. And I'm going to say that this here is the center of my circle. This here is the center of my circle. Basically a diameter. So let me write this down in black. Diameter is basically a chord, but it has to go through, center of circle here. So in this case, this here would be a diameter, right? This guy here is a diameter. Or you can say that this guy here would be a diameter, right? Or yeah, this guy here would be a diameter as well if I cross this midpoint here. Again, this guy would be as well. Again, they're all crossing the middle of the center of the circle, right? So these are all diameters here. However, these are not chords, right? Diameters are not chords. This here, let me figure out. This here are actually, in this case, chords can be diameters. Sorry, diameters can be chords, because again, they're intersecting. This here is diameter, right? This here is 2 points. So which means a diameter could be, diameter equals chords, which equals secants. But not every chord is a diameter, right? So every chord is not a diameter, right? Because again, if you analyze this line here, this is not a diameter. Because it doesn't go through the center of a circle, which means in this case, C is the false statement here, right? Every chord is part of a secant. That's true. It intersects 2 points. Every diameter is part of a secant. That's good because again, diameter also intersects 2 points here. Every chord is a diameter is false, right? And I use this as an example here. This line is a chord, but not a diameter. But every diameter is a chord, right? Because again, if a chord here is going from one point in the circle to another, and this point is a diameter as well. So every chord is a diameter. So let's see, C here is the correct option, right? C here is the false statement. So I believe they explained this correctly. So it says every chord is part of a secant. So that's true because both endpoints lie in the circle. That's right. Every diameter is a secant. That's true as well because a secant is a straight line that goes to infinity and a diameter of a circle that goes through the center of a circle at both endpoints. That's good. every chord is a diameter is false, right? A chord does not need to go through the center of the circle, but every diameter is a chord because it goes to the center of the circle and it touches from this point to another. So this point here is correct. Great solution analysis, good inclusion of diagram. Good. So this was question 8. Let's look at 9 here. We're actually working pretty fast today, which is nice. I'm getting pretty easy questions here. It says which triangle? Oh, whoops. Number 9. Why isn't my pen working? There we go. Number 9 says that which triangle has zero reflection symmetry. Okay, so it says which triangle has a zero reflection symmetry. So when we talk about types of triangles, we have basically 3 types of triangles. We have an acute triangle. So we have something that looks like, let me see if I find you a diagram actually. It might be easier here to find you a diagram. Let's see. So I actually have 4 types of triangles here. And so let me try to draw this out. So this here, I can say that maybe this here is 62 degrees, this is 43, this here is 75. So this here is an acute triangle, right? Acute triangle, because all my angles are less than 90 degrees. Each angle is less than 90 degrees, right? So maybe I'll say each angle is here. Each angle is less than 90 degrees. I can also have a special triangle called a right triangle that we're very, very familiar with. Here, this is a right triangle. And it says that one angle equals 90 degrees. And the rest of these guys, this one doesn't really matter which one these are. So I have 2 triangles here. I have something called an obtuse triangle. So if I had something like this, and this here is an obtuse triangle. Basically, I have one angle that is greater than 90 degrees, but less than 180 degrees, right? So this would be an obtuse triangle. And finally, I have something called a scalene triangle. So scalene triangle, a scalene triangle would be something like, actually something like this, where basically all my angles are not known. So I can say this is X, this here is Y, this here is Z, right? We don't know this here. So this here is actually both an acute and a scalene triangle here. And scalene. So it's asking us which triangle has zero reflection symmetry. So it's asking us, can I reflect these triangles here? In terms of I'll go back to acute first, but right triangle, this point is a symmetrical point. I could reflect the triangle and I'll get something like this. In an obtuse triangle, I could reflect it on this point and get something like this. Let me just see if we can draw this out. I could reflect it on this point and I would get something like this. Something like that-ish. I get something maybe like that. That would be a symmetrical point would be here, because there's kind of a reflection symmetry going along here. But then for an acute triangle, could I reflect it along any point here? If I try to reflect a scalene triangle here, so if I were to, let me redraw this triangle, let me redraw this point here. If I were to try to reflect this guy here into something like this, this wouldn't work, right? If I were to reflect this like this, This here would now be Z here. This is now Y, and this is Z here, right? So this here, I have zero reflection symmetry in terms of my scalene triangles here, because I don't know what my angles are. And if I were to reflect it like this, so if I reflect it along the x-axis here, it's kind of like your hand here, right? So it's kind of how I like to describe a triangle is your left hand and right hand, right? No matter how you superimpose your left hand right hand, they'll never be the same, right? So it won't actually fit the image here. So in this case, this one here would be something like this. You would get basically Z, Y, and X here. So this here would not be it would not be symmetrical, no matter how you superimpose them here. So this solution here is correct. Scalene triangle has zero reflection symmetry. So they show you like this here. So this solution is correct. Great solution and analysis. Okay, this one's number 9. Let's go to number 10. We might be able to finish early, but I actually have more questions for this session as well, just because we didn't really do questions in our 10 p.m. kind of slot here. Okay. So asking how many quarts in 3 gallons? So again, just like my measurement question, did I save my measurement question here? I don't know if I did. Nope. I think when I refresh the page, it left here. That's okay. So it says how many quarts in 3 gallons. I'm going to have to rewrite my measurements here. You can have 1 gallon equals 4 quarts. 1 quart equals 2 pints, and et cetera, right? But we won't really care about that. We only care about this first one here, right? We care about this guy here. 1 gallon equals 4 quarts. So it's asking us how many quarts in 3 gallons, right? So let me write this down. So if 3 gallons, again, I'm going to use this concept of dimensional analysis, right? I have 3 gallons here equals, I have 4 quarts in 1 gallon. I have 4 quarts, I'm multiplying here, by 4 quarts over 1 gallon, right? 4 quarts in a gallon. Therefore, I have gallons cancel out. So 3 times 4 here is 12, and then quarts here. I have 12 quarts here. So this here is the unit I'm using. So 3 gallons equals 12 quarts, sorry. So this here is my solution. 12 quarts is my solution here. And as you can see, 1 gallon equals 4 quarts, which means 3 gallons. I'm multiplying both sides by 3 to get 12 quarts. So the solution here is correct. Awesome. And I believe I have one last question in the set before I have to switch over. And I can do a couple problems from the other set as well. So it says how many zeros are in 5 million? Again, very, very self-explanatory question here. Remember, this is just simply pre-algebra questions, right? So this is how many zeros are in 5 million. So when we think about this question here, we're thinking about decimal places, right? So if let's have a base of 5 here. So this here is 5, right? And this here, if I add another 0, it would be 50. Add another 0, it would be 500. If I add another 0, I have 3 zeros now, would be 5,000. So let me write this down. Let me give you a. So 5 here. This is no zeros. So here's 1 0, 2 zeros, 3 zeros. If I add another 1, I'd get 50,000. Right, 50,000 would have 4 zeros. I have 500,000. Which would be 500,000, which is 5 zeros. And then finally, if I add 1, 2, 3, 4, 5, 6, if I have 6 zeros here, this here is 5 million, right? 5 million would have, I have 1, 2, 3, 4, 5, 6, 6 zeros, like so. So in this question, how many zeros are in 5 million? I have 6 zeros in 5 million. Very self-explanatory question here, very just intuitive question that we have to know. So sweet, this solution here is correct. Solution is correct. Maybe solution is correct. Good analysis. So I'm going to switch over to the other set I was going to do, and maybe do a couple more questions there, because we are finished with this set here. So just give me a second while I do that. I'm going to start this stream here. Sweet. Okay. So this is now this is a new problem set I was supposed to do for this stream, but I finished off the other set from last stream. Basically the questions I didn't do basically at the 10 a.m. slot. So I'm going to go back to number 1. This is now question number 1 again. We have an algebra question here. This is, what is the value of x in the equation set like so? So this here, I'm in box mode, sorry. Says I have here 1.5 in the bracket x plus 4 minus 3 equals 4.5 x minus 2 here. So the first thing I have to do is I have to do distributive property. I'm going to open up these brackets, and how I'm going to do that is I'm going to multiply the first term here and the first term here. I'll multiply here and here. I'm going to open up these brackets here. So I have 1.5 times x, which would give me 1.5x here. 1.5 times positive 4 would give me 6 here. And then I have minus 3. 4.5 times x is simply 4.5x. 4.5 times negative 2 would give me negative 9 here. So now what I can do is I can collect like terms, right? I have 1.5x plus 6 minus 3. 6 minus 3 is simply 3 equals 4.5x minus 9. As you can see, I have common like terms 1.5 and 4.5 here. And then I have some constants here, negative 3 and negative 9. So what I'm going to do is I'm going to move the variable to this side here. So 1.5, if I have positive 4.5 on this x on this side, I'm going to subtract both sides by 4.5. So I have 1.5x minus 4.5x minus 3 equals minus 9. So I'm going to do 1.5 minus 4.5, which would give me negative 3. Negative 3x minus 3 equals negative 9. And then I would have to move this negative 3 to the other side, right? So if I move negative 3 to the other side, I'm going to add 9, right? So negative 9 plus 3 would be negative 6. And I can simply divide both sides by negative 3. This will cancel out. And then these negatives will cancel. 6 divided by 3 would equal 2. So this here will be my solution for value of x in the equation here. So this here would equal 2. So this is x equals 4 is the correct value. So let me just check the work and see if I did something wrong or if this person did something wrong here. So 1.5x plus times 6 minus 3, that's good. 4.5x minus 9. So this here is minus 3. Oh, I did something wrong here. This here is positive 3. My bad. So this here would be 6 minus 3 is positive 3. So which means if I bring this I bring this here, this is still positive 3. Positive 3. Bring positive 3 to the other side, I won't get negative 6, but I would actually get negative 12 here. So this solution is wrong. My bad. So I have this negative 9 minus 3 is negative 12. I'm dividing both sides by negative 3. These negatives cancel out. 12 divided by 3 would be 4. So x equals 4 is our answer, and they got that as well. So this here is a great solution and analysis here. Solution here is correct. Okay, let's do question 2. What is the square root of 180 in simplified radical form? So I have square root of 180 in simplified radical form. So all I have to do is I'm dividing 180 by basically its factors, right? So if I'm dividing by 180 by its factors, I can split this up into root 2 times root whatever 180 divided by 2 is, which is root 90. That's good. I can do this again and I can split this up into, again, I have root 2 here, times, again, I have root 2 again, and then 90 divided by 2 is root 45, right? So again, 2 times root 2 is simply just 2. This is 2 root 45. And then can I break this down even more? I can, right? I can simply divide 45 by 5 to get 9, right? So if I have 2, I'm going to break this down into 2 components. I have root 5 times root 9 here. And then I know it's 2 times root 5 times, I know the square root of 9 is 3, which is good. And then let me see if I can show you visually better. This here is 3. And then 2 times 3 here is 6, right? So this is simply just 6. 6 times root 5 here. And this will be my solution for the simplified radical form of 180 here. So this here is 6 root 5. So let me just check this here. 6 root 5 would be root 180, the square root of 180 here. So this solution here is correct. They did plus or minus 6 root 5. That's fine as well. I really just care about whatever the simplified form here. You could write the plus or minus here because I am taking the square root of a specific number here. So this here is also this here would be plus or minus 6 root 5 here. So this here solution here is correct. Good analysis. Awesome. The solution is correct. This is number 2. Let's move on to number 3. It's asking is if the orthocenter lies inside of a triangle, then what type of triangle is formed? So if orthocenter lies inside a triangle. I don't know why I keep doing that. Lies inside of a triangle. It's asking us what triangle. So how we figure this out is that we have to figure out what is an orthocenter, right? So when we talk about this concept of an orthocenter of a triangle, we're talking about it's basically we have to think about as it bisecting our triangle here. So if I were to draw a triangle, here, I'm taking this point and I'm going to bisect this point, right? So this point here is going to come, whoops, I don't want that point here. This here is going to bisect this point here at a right angle. This point is going to bisect this point here is also at a right angle, and this point is going to bisect this point at a right angle, right? So this here would be my orthocenter of my triangle here. So in this case, if I assume that this here is an acute triangle, if it lies inside of a right triangle, this would be an acute triangle, right? Acute triangle. So that because my orthocenter lies inside my circle, right? Basically this line you can kind of extend this bisecting line here as well till it intersects. And that's how you figure out the orthocenter of a triangle. If I had an obtuse triangle, so let me do a counter example. I would have to do this point is going to bisect this point here, and then it will continue on. This point is going to bisect this point here. This point is going to bisect this point here. And this will continue on here. And this point will bisect this point here. So this point, this point will go towards here and then bisect to this point like that. So basically in this example here, this will also kind of lie in the triangle here. So when we talk about what the answer is here, so if orthocenter lies inside a triangle, then triangle must be acute, right? So here it says again, acute triangle, it's all less than 90 degrees. So this here is good. And here my solution here is correct, right? So this here is a correct solution. So this here would be a great solution here. I'm gonna see if I can draw my obtuse triangle just slightly more obtuse. So I'm gonna show you if the orthocenter lies. I can have an example where an orthocenter lies outside my triangle. So just give me a second here. So if we were to draw something like this, I have this point C. It's going to make a right triangle like so. Remember, bisecting it means it has to also make a right triangle, right? So this here would make a right triangle here. This one would make a right triangle. This one wouldn't even make my right triangle here. If I want to make a line here, this would be my line, because this would extend here, and this would be a right triangle here. And finally, for B, if I want to make a right triangle here, I would have to basically extend this line here, and this one would look something like, give me a second. So in here would look something like this. I would have to be a line and something like that. So in this case, my orthocenter would be somewhere around here, which is outside the triangle, right? Because these are bisecting lines in different triangles here. So this one my orthocenter would lie outside. Let me write this out here. Orthocenter lies outside the triangle. So it really depends on what triangle you're looking at here. This one would be probably a scalene triangle, would have a orthocenter that lies outside. But for acute ones, remember they all intersect here at 90 degrees inside the triangle. So this solution here is correct. I wish you included bisecting lines to show where the orthocenter lies in the acute triangle. That's good. So let's maybe do one or two more, and then we'll call it a day here. So it says the perimeter of the rectangle MNOP is 146. What is the length of the longer side? So I'm going to draw this out. MNOP. So it says the perimeter here, perimeter is 146 units. And I have the lengths 3x plus 3 and 2x here. What is the length of the longer side? So I care about what is the length of the longer side, which is this guy here. So this is L. This here would be W. So if I want to find the perimeter is 146 meters, but I have the perimeter of a triangle. So what is the perimeter of a triangle? The formula for a perimeter of a triangle is P equals 2 times L plus W here. This here is a perimeter of the triangle formula. And what we can do is we can substitute these variables as length and width, right? So I would have P would equal 2 times length here. Length is 3x plus W. Or 3x plus 3, not W. 3x plus 3 plus, and width here is 2x here, right? So we have 2 times 3x plus 3 plus 2x here. So we can solve this algebraic question. 2, we are going to collect like terms. 3x plus 2x here is 5x plus, and then plus 3 here, right? And then P would equal 2 times, either I'm going to use distributive property to figure this out here. 2 times 5x here is 10x. 2 times 3 here is 6. So I have 10x plus 6. And this equals the perimeter of the triangle says that is 146, right? So I can substitute 146 for my perimeter here. So I can move now 6 to the other side here. I would subtract 6 from both sides. 140 minus 6. 146 minus 6 here is 140 equals 10x. I can divide both sides by 10 to get me x would equal 14 here. X equals 14. However, I'm not done with the problem yet. It's saying what is the length of the longer side? And I told you that length equals 3x plus 3 as given like so. If x here equals 14, so 3 times 14 plus 3, then length would be 3 times 14 here would be 42 plus 3, which equals 45 units. So length here is 45 units here. So again, therefore, the length of the longer side is 45 units. That's correct. They also got x equals 14. They said the perimeter of the triangle is 146, and then they did 3x plus 3 plus 2x plus 3 plus 3 plus 2x here, which is basically the perimeter of our of the formula, of the rectangle formula here. They got the exact same thing, x equals 14. Therefore, longer side here is 45. This solution is correct. Great. Solution and analysis. Let me see if I can squeeze in one more depending on time. I think I can here. This will be my last question. That is question 5 here. It's asking, how do you simplify the square root of 200? So I have square root of, and it says simplify here. So we talk about simplify, we're talking about basically the exact same thing, writing them in terms of exact same values. So again, I'm figuring out how can I break up this radical into 2 parts. Again, I can definitely just divide by 2. So I'm going to put 2 here times, I'm going to divide 200 by 2 here, which is 100. So this is square root of 2 times 100 here. And I know the square root of 100, right? The square root of 100 is simply just 10, right? So I have root 2 times 10, right? Remember, 10 squared is 100 here, right? If you don't, and again, if you don't know that, then I can simply just continue to break this down, right? Therefore, this here equals 10. However, if I didn't know that the square root of 100 equals 10, I can simply just do, I can divide by 2 again, right? So again, dividing 100 by 2, root 2 times, again, 100 divided by 2 is root 50. I then now have square root of 2 times square root of 2, which is simply 2 root 50. And then I can also break this down again into 2 parts. Again, I have 2 times, again, I can divide by 2 to root 50. Again, root 50 divided by 2 would be root of 25. And then now you can see that I have 2 times root 2. And we all should know what root 25 here. This is simply just 5, right? Root 25 is equal to 5. Then I can do 2 times 5 here is 10 times root 2. So therefore, the answer here is 10 root 2 is in simplified form. However, we could have solved this problem even in this step here, right? We could have done this solution here. At this step, when I get root 2 times root 100, if you know that root 100 is 10, then you simply have root 2 times 10, which is simply just 10 root 2 here. So, but either way, both of them give you the solution here. It's 10 root 2 and 10 root 2. This one says plus or minus 10 root 2, perfectly fine as well. You can include the plus or minus as well, but I think they're just asking for a simplified form here. So this here is a correct solution. Good solution and analysis. Yeah, so they broke it down again to they did prime factorization, so they just divided by 2, and then you can simply you got root 2 times root 100 here, which is simply root 2 times 10. So the solution here is correct. So that's all the time we have today. Again, we have more problems with grade 9 math. Again, I didn't get to some of the problems at 10 a.m., but what I'm going to do is I'm going to save these problems for probably Monday's stream, and then we will talk about these problems then. So again, if you're watching for the first time, thank you so much for tuning in. Again, my name is Joey. I'm here. I'm employed by OneClass to kind of verify these solutions for you as well. I'm going to stream again probably. I'm going to stream again back on Monday, like always. Again, if you want to tune in, Monday, Wednesdays, and Fridays are always math, and Tuesdays and Thursdays are always chemistry. So without further ado, again, thank you so much for watching. We will continue on Monday. Again, thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.